Question 3.12. This is a somewhat descriptive kind of a question. A stream of photons from an unpolarized source passes first through a polarizing beam splitter PBS and then through a second polarizing beam splitter with its optic axis at an angle theta to the vertical. The second beam splitter is positioned so that only the vertically polarized output from the first beam splitter is incident on it. Single photon counting detectors are placed at the two outputs of the second beam splitter. On the assumption that the detectors are perfectly efficient and that there are no losses in the optics, calculate the probability per photon of recording an event on each detector. So first let me draw the experimental setup in question. So what we have is we have a source, of light which falls on a polarizing beam splitter and because of the beam splitter some part will be transmitted and some part will be reflected, and this is then incident on a second polarizing beam splitter. Let me copy paste. However, the angle of this polarizing beam splitter from the vertical is theta. Let me draw that first. This is the transmitted part of the light, then this is the reflected part of the light, and there are detectors in these two arms. And the angle that this polarizing beam splitter makes with the vertical is theta. So the source is unpolarized light, and because of the polarizing beam splitter, this light is vertically polarized and this beam, the reflected beam, is horizontally polarized. So transmitted beam is vertically polarized, reflected beam is horizontally polarized, and this horizontally polarized beam falls on this second polarizing beam splitter, and we need to find out the probabilities of detection at detectors T1 and T2. So let me also draw the cross section of the polarizing beam splitter. So the incoming light to polarizing beam splitter 2 is vertically polarized, whereas the axes of the polarizing beam splitter are at an angle theta. So this angle right here is theta. So this is the angle that the polarizing beam splitter makes with the vertical. Sorry, I think there was some technical glitch. I think something went off. Let me repeat myself once again. So the probabilities of detection of photon at detector D1 is P1 equals to 0.5 cos squared theta and P2 equals to 0.5 sin squared theta. And note that I had written these electric field components as E cos theta, E sin theta. This is coming from the classical sense and also from Malus law, but this very easily translates into the quantum regime as well, wherein instead of the electric field amplitudes or the intensities, we work with probabilities, and instead of electric field as such, we deal with the number of photons. So if the intensity becomes half in the classical sense, that simply means that only half of the number of input photons are getting transmitted and half of the input photons are getting reflected. So at a beam splitter, classically we say if it's a 50-50 beam splitter, the intensity of the reflected beam will be half that of the input intensity, and intensity of transmitted will be half that of the input. So both reflected and transmitted intensities will be half of the input intensity. Similarly, in the quantum sense, we will say number of photons passing in reflection and in transmission are half as the number of photons in the input. So classical to quantum is a very easy transition, so to say, wherein electric field amplitudes are replaced by number of photons and intensities are replaced with probabilities. So thus, if we say that the electric field is E cos theta, that means and intensity is E squared cos squared theta, that is proportional to cos squared theta. That simply means that if there are n number of input photons, then n cos squared theta photons get transmitted. So let me write, if input photons, and remember this is my input over here, input to the PBS2, input photons which are vertically polarized, and this source over here is unpolarized. So input photons to the PBS2 they are vertically polarized, and let us say they are n in number. Then output at PBS2 in the case of reflection is proportional to, or rather equal to, first I'll write proportional to because I have not taken into account the 50-50 splitting. So this is proportional to n sine squared theta, the output photons, number of output photons, and at transmission this output number of photons is proportional to n cos squared theta. And because of the 50-50 splitting, we will have this factor of 0.5. So because this polarizing beam splitter is a 50-50 splitter, so 50% goes in reflection, 50% goes in transmission. So the number of photons are actually input, then half of them half of the photons go in the transmission and half of them go in the reflection. So if input is n, then n by 2 is in each of reflection and or transmission. So the probability, which is the analogous quantity to intensity, number of photons will just be sine theta cos theta. So the probability, which is proportional to intensity, will be proportional to this sine squared and cos squared theta with a factor of half in front of it. So this was a question on polarizing beam splitters and detection probabilities.